Water-carved rock formations, fractured boulder fields, wildflowers and sandstone glades. Just southwest of St. Louis, Missouri, LaBarque Creek Conservation Area is full of fascinating features. Join Ozark Outsider on a naturalist walk to explore the geology and botany of this special natural area. Although this site covers over 1,200 acres, we're going to focus on features found along the dedicated loop trail. Hiking clockwise, this takes you south along an upland ridge, then loops back north down a creek valley. The bedrock here consists of two major rock types. Most of the uplands are underlain by limestone and dolostone, carbonate rocks deposited in a warm, shallow marine environment like today's Gulf of Mexico. Below this is the distinctive St. Peter sandstone, composed of fairly pure quartz sand deposited in a shoreline environment, with features suggesting both windblown dunes and marine waves. The St. Peter is a prominent formation in parts of eastern Missouri, often forming major cliffs like this one in the nearby town of Pacific. Recognizing where the bedrock changes from the overlying carbonates to the underlying sandstone is key to understanding many of the features you'll see on this trail. Look at the main north-south valley in this terrain model and see if you can identify where its shape changes suddenly. In the circle, the valley floor is fairly smooth and gentle. But just downstream, in the oval, notice how it changes abruptly to a deeper, broader gorge lined with sharp drop-offs? Loosely speaking, that change marks where the creek starts cutting down into the sandstone, which erodes very differently from the overlying carbonates. Since the rock layers here are essentially flat, like a layer cake, the sandstone forms the lowest parts of the valley, while the carbonates form all the higher slopes and ridges. This image isn't meant to be exact. We didn't map the entire contact. It's just meant to help visualize how the shape of the landscape interacts with the low-lying sandstone. Enough mapping, more hiking. As you head into the uplands, the trail passes through mostly open woodlands on mostly gentle slopes. Look for occasional ledges of carbonate rock, some of which are being pried apart by tree roots. At one point, you'll pass through a stretch where one layer of carbonate bedrock has been fractured and eroded into a pretty sweet boulder field. How do you know these are carbonates and not sandstone? Beside the fact that you're up on a ridge here and well above the valley floor sandstone, you can look for fossil evidence, like these tracks left behind by marine creatures burrowing through seafloor mud. And as you descend back down toward the valley floor, how do you know when you've transitioned into the sandstone area? One way is to pay attention to the trail surface. In carbonate areas, this will generally feel clay-like. See how it smears under my finger? But walk just a little bit further, and the trail surface suddenly gets all sandy. See how it bunches up like beach sand under my finger? And sure enough, as we look around, there's a line of ledges along the creek valley that mark the beginning of the St. Peter sandstone. This little glen is full of neat sandstone features. Here's a mini waterfall coming in over the top of the sandstone. We're going to return to that particular pattern. And over here, there are more sandstone outcrops along the valley wall. And down here is one of the coolest single features along this hike. Sandstone is often easy for water to carve, and here the stream has eroded away two drain holes bypassing what was already a pretty neat waterfall. And here are some other formations typical of the smooth, curving nature of water-carved sandstone. But how do you know that this is sandstone? The rock is composed of millions of quartz grains, all rounded like beach sand and cemented together by time, pressure, and other minerals. See how sparkly it is? This purity makes the St. Peter sandstone a commercially important formation in Missouri and elsewhere. Visit the Jensen Overlook in nearby Pacific, Missouri for a great view of a modern quarrying operation. From here, the trail follows a distinct ledge atop the sandstone cliffs, with numerous examples of another role the sandstone plays in shaping this area. In this open glade, you can see several seeps of water emerging from near the top of the open rock. Remember the stratigraphy here, with carbonates forming gentle slopes above and sandstone forming more eroded landforms below. Our theory is that shallow groundwater is filtering down through the carbonate rocks but being excluded by the sandstone, moving sideways when it reaches the latter and emerging at the surface where the two formations meet. This is a little counterintuitive, because sandstone is often very permeable to water, and indeed it commonly hosts aquifers. But in the Ozarks, carbonate bedrock is often highly fractured and internally eroded, sometimes to a Swiss cheese texture, meaning that it becomes so permeable to water that sandstone actually is more resistant to groundwater flow. This pattern may play a role in the location of various Ozark springs, as discussed in our video on the current river. A slightly different possibility here is that there's a thin layer of shale or other impermeable material right at the boundary between the carbonates and the sandstone, marked here in green. And that layer is what's actually redirecting the groundwater out into surface seeps. You can see such a layer in this photo from Pacific, Missouri, where a seep emerges right where the green staining marks the transition between carbonate above and sandstone below. In any case, as you walk the trail along the upper sandstone rim, you'll see a repeated pattern of wet seeps emerging just above the trail and running off into little waterfalls cascading over the lip of the sandstone ledge. And here's another one following the same pattern. As fascinating as the bedrock is here, it's not the only thing to pay attention to. This is an official Missouri Natural Area, a designation that implies special botany and ecology. And in turn, bedrock often influences where certain species are found. In the open woodlands, we found common spring-flowering species like serviceberry, often called sarvis in the Ozarks, as well as bloodroot. The sandstone areas were particularly interesting, hosting plants that prefer either very dry or persistently wet conditions, sometimes within mere steps of each other. Dry glades hosted species like prickly pear cactus, the impeccably named bastard toadflax, hairy lip fern, and large flowered fame flower, which I keep wanting to call flamethrower. Not far away, wet seeps hosted species like American tree moss, swamp saxifrage, and snakewort, a kind of liverwort. No matter what time of year you visit, there will be something neat to see and identify. Check out all of our observations from this spring visit on iNaturalist at the link below. LaBarque Creek Conservation Area is a great spot for a hike, but if you pay attention and study your surroundings, it can be so much more. Appreciate how the bedrock geology controls the location and the nature of seeps, waterfalls, and outcrops, and take a closer look at the diverse plant communities that are hosted by different rock types and environments. The more you observe, the more you'll get out of your hike.